All right, let's do 1.4. So if I look at number 5, it says given the function f of x is equal to x squared plus 2x and g of x is equal to 6 minus x squared, it wants us to find f plus g, f minus g, fg, and f divided by g. And then find the domain for each. Well, the first one is just this thing and this thing. Okay, so what I'm going to do is I'm going to do this. I'm going to, let me copy those. So first thing I'm going to do is I'm going to add them together, but I need to be careful and add all of this and all of this. And so what you'll get is you should get x squared and the negative x squared are going to cancel out. And so you should just get 2x plus 6. Now, if I take one minus the other, again, parentheses are so important that you're taking the entire function f minus the entire function g, because now distributing through this negative, caution, use parentheses as often as you can. So here, using these parentheses, I get x squared plus this. Distributing through the negative, I get negative 6 and positive x squared. So now I have 2x squareds, a plus 2x, and a minus 6. Right? For the last one, f, or the penultimate one, the next to last one, if I do f times g, it's going to be this times this, and I'm going to FOIL, or distributive law twice. It's just that and gives me this. That gives me negative x to the 4th. There's nothing left to multiply her by over here. So 2x hits that and gives me 12x. And this gives me negative 2x cubed. Double check my answer. So this is that, this is that, this is that, this is that. Okay. So highest power is negative x to the 4th minus 2x cubed plus 6x squared. And then plus 12x would be what that function turns out to be. Okay. Boop. Boop, 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 boop. Why did it do that? That's really weird. Okay. Okay. Then f divided by g, if you'll let me take that over here, it's going to be you take the f function, which is this, and divide it by the g function, which is this. And there you go. So for each of these, we worry about domain. Well, since the domain of each of these is all reals, it's going to turn out that every time the domain of all of these is going to be negative infinity to infinity for the first 3. Because remember, the only two things that we worry about, at least so far in this course, is division by 0 and square root of a negative. So here in this last one, we worry about where the denominator is 0. And that means that we end up getting x is equal to either plus or minus radical 6. So those are the two values that you don't want for this new function. So that means I've got the square root of 6. Means I've got negative square root of 6. You don't want to be those, but you're allowed to be whatever you want. So that means the domain of f divided by g is going to turn out to be negative infinity to negative root 6, negative root 6 to 6, negative root 6 to root 6, and then root 6 to infinity. And yes, if you remember, it would be amazing if you can remember to put a u in between those for union. It means that you can put in any value in here, or any value in here, or any value in here, because union means or. So that's number 5. Let's look at number 9. So number 9 is the exact same process, except we're now doing the function f of x is equal to 3x squared, and g of x is the function square root of x minus 5. X minus 5, they want us to find f plus g, f minus g, f times g, and f divided by g. So first, if we add these two, I'm going to have this and this. So I'm going to copy that for use in a second. So the first thing we're going to do is add them together, and that's really all you can do is just add them like this. think it's pretty clear that the domain of f plus g, the only really bad part is going to be this, where I want the radicand, thing under the radical, to be greater than or equal to 0. So that means but x must be greater than or equal to 5. That means you can be 5 or greater, so the domain is going to be 5 to infinity, including 5. I think if we do f minus g, again, it's going to be this minus this. And so I think from the same reasoning as before, you are going to find out that the domain in this case is also, boop, is also 5 to infinity. When we multiply them together, you're going to get this times the square root of x minus 5. And again, I think the only thing you want to make sure that you don't do, if you're doing the domain of fg, again, x must be greater than or equal to 5, because this is still the only problem every time for those three functions. Well, now for the last one, f divided by g, if you allow me to put that over here, that's going to be the f function divided by the g function. And why is that great? We're done, but notice here, we have the same problem that we did before. We do not want the radicand. It must be greater than or equal to 0. But in this case, we also do not want the denominator equal to 0. So it means this can't be 0, which means x cannot be 5. So this one is telling us that x can be anything, but it can't be 5. And now do you see where they overlap? Yes, you guessed it. The domain of f divided by g is just going to be, we call it the domain of f divided by g, is just going to be not including 5 out to infinity. Because now we worry about division by 0. So that is number 9. We now need 11. So let's maybe do some blue. 11. Okay. So it has f of x is equal to 2x squared plus 1. This one. And g of x is equal to 3x minus 5. It wants us to find the following. Okay. Let's see. So in this case, sorry, I don't know why that did what it did. In this case, for part A, it wants f of g of 2, which we know just means first find g of 2, which is 3 times 2 minus 5, or 1, and take that 1 and plug it in to the function f. So f of 1, if I come over here, f of 1 is just 2 times 1 squared plus 1, which is 3. So f of g of 2 is just 3. For part B, it's f of g of x. So again, we just take the f function. We take g and plug in x. So g I plug in x. Well, look, it's here. G plug in x is just 3x minus 5. So that's an answer, right? But you take that whole answer and just plug it into f. Well, what does f do to things? F just, if you plug things in, like 3x minus 5, it just takes that 3x minus 5, it squares it and multiplies by 2, and then adds 1. That's what f does. So that means this is what f of 3x minus 5 is going to be. It's just going to look like that. I think you can make that look nicer by expanding what got squared, multiplying this by itself. 3x minus 5 times 3x minus 5. You're going to get 9x squared minus 30x plus 25. So this is 9x squared minus 30x plus 25. Don't forget about your plus 1. So this, when you square it, just turns out to be this. But then you distribute through that negative 2 and get negative 18x squared plus 60x minus 50 plus 1. So that just turns out to be burp, burp with this, and minus 49. Okay? So that's f of g of x. But then in part C, let me go here. Let me go duplicate. Okay. Then in part C, I have the exact same functions. So in part C is in cat, they want g of f of x. And what does that give me, g of f of x? That just means I take my g function and I plug f of x into it. But what does g do to things? It takes 3 times what you give it minus 5. So if I plug this into the function f, that's going to go there. So now when you distribute, you get 6x squared plus 3 minus 5, which is 6x squared minus 2. All right. Then for D, it wants to find g of x. Hey, what's up? Thank you very much.
No problem.
Have a good day.
You too.
So g of x is just you take the function g and you plug it into g. So the function g is just this. And if I plug it into itself, g does 3 times whatever you give it minus 5. But if I plug g into itself, it's like an iteration, I get that. To make it look nicer, I distribute and get this, which gets me 9x minus 20. Okay, I'm going to duplicate that page. All right, so that's D, and then part E. E is an egg, is going to end up being, what, f of negative 2, which means first you plug in negative 2 into f, and then take that answer and plug it back into f. So what is f of negative 2? Well, f of negative 2 means you just put negative 2 inside of f. You get 2 times 4 plus 1, which is 9. So that means we're really just taking f of 9. But f of 9 is 2 times 9 squared plus 1 is 2 times 81 plus 1, which is 162 plus 1, which is 163. Okay, now I need 91 and 93. So 91. It says a function gives pain levels on a pain scale. So D is the number of milligrams of a drug, and A is pain on a scale of 0 to 10. So that's the pain. It turns out the milligrams of drug is modeled by M of T. That, if you give me a certain number of minutes, so that's time in minutes, and D is a drug. D is the drug in milligrams, and pain is on a scale of 0 to 10. This is this, and M. Hey, what's up? That's okay. This is drug. Oh, no big deal. Just let me know if I. Oh, I am. I'm recording a video, but it's okay. No big deal. Drug milligrams. And so what do you need to do? You need to just think of, again, it's a 2-step process. So which of the following would you do if you wanted to determine when the patient will be at a pain level of 4? So I don't know, 4 is equal to some pain level, right? But if I wanted to know when, what this tells me right now is for a specific drug or dosage amount, it will give me the amount of dosage for a pain level of 4. But if I want to know the time, then I just replace that drug amount with a m of t. And so now this is going to be an equation with only t's in it that you can solve for the time to give you a pain of 4. And so that's going to be C as in cat. That's what I want to solve this. And that is C on that multiple choice question. And then 93. 93, it's rain. So yeah, we got blue. So little rain droplets are coming down and they hit the water and then they make circular ripples, yes? Okay, and it turns out that the radius of that thing is a function of time, where it's 25 times the square root of t plus 2, where t is the time in minutes. So that's time in minutes, and r is the radius in inches. Wants to know find the area as a function of time. Well, I could say usually I think of area as a function of the radius. So now really area is a function of radius, so it looks like this. Well, notice I can actually plug in r into this equation. Well, if a of r is this, well, notice if I plug in here, what you're really going to have is a of r of t is going to be equal to pi of r of t squared, right? Well, this thing on the left, that's just a as a function of time. But what did we say r of t was? It is 25 square root t plus 2 is what all this is. And that thing's going to get squared, right? Well, if you square it, 25 times 25 is 620. No, 25 times 25 is, oh man, she doesn't have number lock on. 25 times 25 is 625. I was right. So 25 squared is 625. And then t plus 2, if we square it, is just going to be t plus 2, that square root squared. So what you really have is 625 pi times t plus 2. You could just leave it just like that. That's your answer. Great work. Keep up the good work, and I will see you next time.